Humic and fulvic acids are gaining a lot of ground in agriculture, and it's easy to see why, especially with some new scientific advancements, and that's what we're going to talk about today. Welcome to Redox Grows. I'm Jim Morris with Redox Bionutrients. This is the first in an occasional series we'll have where we take a deeper dive into science and agronomy, and I'll do that with Dr. Giff Gillette, our head of research. Giff, thanks for your time.
I'm excited to be here and talk about something I love, which is biostimulants.
Well, I appreciate your enthusiasm and your hard work, and this is going to be a great subject, and we'll have many more to talk about over the coming months. Giff grew up on a potato farm in Idaho. His education culminated with a PhD from the University of Idaho. And let's start with the very basic, Giff. How do you define humics and fulvics? My understanding is that they are ancient, plant-derived, often from linardite.
Yes, that's a good definition, and I think of humics and fulvics in agriculture as one of the greatest areas of opportunity for a farmer to bring biology into his system and to really meet the needs that are being placed upon us in agriculture right now from an efficiency standpoint. And so, more specific to your answer, what are humic substances? They are really probably best thought of in three fractions or sizes. Humin, which is the largest, more insoluble. Humics, which are medium size. And then fulvic acids, which are smaller. And we typically think about those in terms of their size. I think a lot of times we refer to that size as carbon chains, but a better, more descriptive, more accurate view would probably be on molecular weight. And then the other one is solubility. So we go from our small sizes, fulvic acids, more soluble, to our less soluble in water, humin fractions, and humic are in the middle. There's a lot of different ways to differentiate these categories of humic substances. Those are some of them: size and solubility in water.
We're going to dig more into that, but I also would like to ask you, we should discuss what bionutrition is from a redox bionutrient standpoint. We have superior nutrition and biostimulants, both very important. You need both to get the best results. So before we get more into humics and fulvics, let's talk a little bit about bionutrition.
Very good. So I think the humic substances category is the best place to start talking about biostimulants. When you think or when you hear bionutrients as part of redox or in other places in agriculture, sometimes it's biofertilizers. What's the bio part, right? Well, there's 8 different categories at least of different biostimulants that can make something a biofertilizer or a bionutrient. We utilize 5 to 6 at least of those categories. We don't utilize all of the biostimulant categories that are combined with nutrients, so they're reacted. And the one that we utilize the most at Redox is the humic substances biostimulant category. That is the biostimulant that is reacted with a nutrient the most often in the product offerings that we have. We also have seaweed extracts. We also look at protein hydrolysates. Plant extracts is a really important aspect with some of the technology that we have coming out this year. So that kind of, I hope, answers the question, encapsulates what is a bionutrient, because we get that question a lot. And when you're talking about 8 different categories of biostimulants, the one half of the bionutrient aspect, it does require some nuance and some understanding. What are those different categories and what are you bringing to the table when you react a nitrogen UAN32 or a phosphorus source with a biostimulant? And the exciting thing is regardless of what that biostimulant is, it can provide in an agricultural system or in a cropping system some benefits that haven't been seen in agriculture prior to, right? Combining a biostimulant with a nutrient.
I think that's an excellent point. And here at Redox, we have a unique niche. Yes, there's over 1,000 different companies in this biological realm, but no one has 2 generations of family involvement, 30 plus years as well, and a proven track record throughout the US and internationally. So back to humics and fulvics, the yield response. What is their impact on a yield response?
Yeah, so that's a great category. One of the two most documented benefits to crops from a humic substance, whether that be a fulvic acid or a humic acid, is one, an increase in root growth or an increase in root biomass, and then the other one is an increase in nitrogen uptake. Those are the two most common. But there are I have identified, there are 60 different impacts that a humic substance can have on a crop. And they can have impacts that a lot of times I think when we think of humic substances, we think of the benefits to the soil. We think about soil health. And that is certainly an appropriate view. But when it comes to agriculture, ultimately yield is the most important factor or benefit from any input that we're looking at. And so because of those benefits of root growth, we often see increases in yield, whether that crop be a perennial or annual row crop.
Interesting possible change in farm philosophy, doing more with less for generations, and it's because of what we knew. More was better with NPK, particularly nitrogen comes to mind. But the quality over the quantity aspect, tell me about that. Why can you use less and still have a great return and excellent ROI?
This category is the key to sustainability in agriculture. It has put us on the path. The technology is there. We have the ability, not in very many industries, to meet the call for sustainability, to do more with less, and humic substances are it. They do it. They get us there. They have got us there. The technology is there. We have the solutions. And so it's really exciting. Now, there are some really important aspects to understand about humics. When we just look at a label, the labels don't do a grower any favor. You talked about 1,000 different companies in the marketplace. What a challenge for farmers and growers to find solutions when they're there. The problem is when we look at a label, it doesn't tell us anything about the quality of that humic substance. Most of the time, it doesn't even tell us what fractions of carbon, whether they be fulvic or humic or human, let alone the functional groups associated with those different fractions. It doesn't tell us anything about that, typically, on a label, which is really quite mind-boggling. Really, the focus has just been on what's the percentage of humic acid. And so one of the things that we have tried to train, even within Redox and among the agronomists, is that we need to refer to the given product as a humic substance, not just a humic acid, so we're not overlooking a really important fraction, fulvic acids, that can be in a product but not on the label. And so that's a really important question I think that a person can ask is, one, what are the fractions in your humic acid? That's typically what is said in a day-to-day conversation on a farm or about products is humic acid, and we put so much focus on it. And the humic acids are really important. But what about fulvic acids? And that question should be asked. And even if that percentage is 0.5% of a fulvic acid, that has real value directly to a crop. More specifically to direct impacts, fulvic acids, because of their nature, they're more bioactive and they're more immediately available to impact a plant, a crop, in season, even at 0.5% in tandem with that humic acid product, right? That's a 6%. And what does that mean from a 6% standpoint? So what are the other fractions in there? In a given humic product? And then I think the other question is that given humic substance, humic acid, fulvic acid, is it fractionated beyond just extracted? Every product in the marketplace is going to be at least extracted once, meaning that Leonardite is going to be manufactured, it's going to be slapped with an acid, most likely, a potassium or sodium hydroxide, and you're going to get the stew. And the reality is, and this is really important, I want to be fair because I'm a huge fan of biostimulants and a huge fan of humic substances, but we do need to be aware that just one extraction off of a Leonardite, what that is. Well, what that is, as you mentioned earlier, is it's an ancient conglomeration of highly compressed, different living what were once living organisms, plant and microbial matter. So it's variable, and that in and of itself has value, but even by definition, what to me is one of the experts, he refers to as what's in that stew. He calls some things in that initial stew of extracted humic substance contaminants. I wouldn't go far as to call them contaminants, but certainly could be antagonisms. And so the important thing is that we get that to that next step, and that is the question, I think, for any given humic substance or humic acid in the marketplace is, has it been fractionated beyond that initial extraction, and then has it been fractionated after that, where you've removed maybe some of the things you don't want and you've selected for the bioactive compounds you do want to get one of those 60 plant responses, right? We're not after all 60. We're definitely targeting specific plant responses in different cropping systems and in different scenarios where you have different things limiting your yield potential. So I hope that kind of answered your question in terms of some of the important questions to be asking about a given humic acid.
Yeah, I love that, because you grew up in a farm environment, you visit with farmers all the time, and we don't want to be so far removed where we're simply talking about science. We have to have practical applicability, and I really appreciate that. I want to talk about fractionation a little more. My understanding, one of our agronomists mentioned this, is you have a big candy dish with a lot of candy in it, like the one we have here that gets taxed every day, and there's some Reese's peanut butter cups in there, and you just want those. So you get those out, so you have a very specific thing that you're going for, a specific benefit. A lot of other places don't do that. Tell me if that's right. I mean, amplify that a little bit. Why is fractionation so important? It's a costly step, but we know so much more now than we did many years ago. So tell me more.
Yeah, I think that's a great analogy. Another really good analogy that we see every day and is actually chemically, in terms of a chemistry standpoint, is very accurate too, is when you're at the pump, right? And you have different gas options, right, that have been fractionated at different levels. And I think that's a great analogy as well. And so the one thing that's, I think, like I mentioned earlier, is one, there are some things in that aren't bioactive and they need to be removed. Another component is there's different functional groups that we might be interested in when we fractionate. And so we might be targeting those. We might be targeting direct versus indirect impacts to the plant. For a soil response, we would be targeting different bioactive compounds, accumulating those to get that response in the soil. And so one of the neat things about Redox is not only have we been able to attach for like example H85, not only have we been able to accumulate and fractionate and target those bioactive compounds that we know elicit certain responses, we've also on the back end of that formulation and effort and target been able to quantify the ability to do that. So let me give you some examples. From a soil standpoint, we have been able, through a university collaborator, through two different cropping systems, in apples and in strawberries, been able to fractionate to a point that we've been able to get a response out of the soil for soil health. And the two measures that we were particularly interested in was an increase in soil respiration and enzyme activity, which we know those enzymes are opening pathways. They're the key to opening these pathways that are important in a cropping system. And so not only were we able to, that was really the goal, fractionating H85 for those soil health benefits, that led to an indirect benefit to the crop in both apples and strawberries that led to an increase in yield. And so it's really fun as a scientist to be able to put those pieces together and get the outcome that we were seeking for and quantify it. And so that was just one like tandem trial that we did across crops to quantify the benefits of fractionation, looking for a specific response, a soil response in that case.
That's fascinating. So Humics and Fulvics are in virtually all of our products. You mentioned H85, and I've spent a lot of time covering a lot of stories in agriculture. When I've heard you speak on this, my quote meter keeps binging because you say so many positive things about it. You just listed some of the positives. How excited are you about H85 and its benefits and our understanding of what it can do.
You know, to be honest, some of that excitement we kind of went over. I don't know if people are aware of this, but I mentioned earlier two of the things that are documented most for humic substances. One of them is increased root growth or biomass below ground, but also nitrate uptake. And so I think there has been an opportunity, to be perfectly honest, in the agriculture space. We have missed the opportunity to take advantage of the nitrate uptake. We've quantified that ability to reduce nitrogen inputs by 25% and increase yield, and we've done that over and over again across multiple crops. And so while I am excited, I also kind of have a little heartburn, right, that we've overlooked that opportunity. And I'm not saying the company has, that is a tremendous benefit that it's in our product catalog as one of the benefits of that technology. And that is, I do want to specify that access in the nitrogen cycle is in the soil. And it's through nitrate uptake. Not only have we quantified that ability, but from an environmentalist, as a biologist, it makes me very excited that we have a technology that we've documented with the University of Florida to decrease nitrate leaching, right? And that is a huge environmental component where we do have restrictions in certain areas of the country because we have nitrate leaching issues. And so we've been able to quantify that with H85. That's very exciting because we do have limitations. Those are real, they're placed upon growers, and we have some solutions. And we have the science to back them and for people to have confidence in those bionutrient approaches.
That is really exciting. And when you look at nitrogen optimization, RDXN comes to mind as well. New product for Redox, 10 years in the making from Darren Moon. We've talked a lot about that, and we'll be talking more about that, I'm sure, as we take these deep dives. This all leads to plant charge balance, redox homeostasis. What is it? How vital is it?
Yeah, I think we can put that in the context of this conversation with humic substance. How do you evaluate a given humic acid? What are some questions that you can ask? We already mentioned a couple of them. One of them, an additional one is, what impact does a given humic substance have on the charge in the soil and on the charge in the plant? And by definition, humic substances, for example, are known to reduce the charge in the soil, lower EH, lower redox potential. And that is another great way to evaluate a given humic substance. It's hard. We have, and through some of our own efforts, looked at different humic substances in the marketplace and done lab analysis, and that's hard for a grower to send in and pay a bunch of money to look and see, did that analysis come in? Does it have that percentage of humics? That's a really important one. And that's hard to do, but an easier way is to measure the actual product and to measure EH. You can do that with a given humic substance. And what we have found when we have looked at different humic substances in the marketplace, there's a correlation between fractionated humics and the EH value. The lower the EH value, the more likely you have a fractionated humic substance. And again, that's just referring to that value. What does that mean? I like to think of redox potential, or EH, as giving the plant or the crop the ability to adapt. A lot of times our plants are in extreme charge, especially late in the year, under drought stress, salt stress, potentially later in that year. It's stuck in a state, one, that's not efficient, and two, that doesn't allow it to adapt. So typically a humic substance is going to lower that EH of a given crop, as well as in the soil, because you have both. You have EH in a plant, you have EH in the soil, and we need to manage both of those. We need to balance them. We need to find the optimum level that crop needs to be at. And humic substances are a great way to manage EH, or charge balance, in the soil and in the plant. And it's something that can be measured with just one device.
That's cool. Just to boil that down, everything that goes in the soil has a positive or a negative charge. You need to have it balanced for the plant to be at its best, to be healthiest, and to produce the optimum yield and quality. Is that correct?
Yes, and to add to that, the positive measure that we look at is pH. We look at pH. When we're looking at the negatives, we're looking at electrons, we're looking at EH. And so we look at both of those and we overlay pH and EH in this understanding of redox potential and the redox cross. Those are both important ones. And we've looked, I think everybody's really familiar with that. And that brings up another value that someone can look at for a humic substance is just what is the pH of a given humic substance. And generally, if you're closer to that neutral pH, you've probably got an extracted humic substance, whereas most fractionated ones that I've seen have a higher pH. And so that's another maybe basic way to look at or evaluate what kind of humic substance do you have at your disposal.
You mentioned, Giff, that we have a way now we could test it. Walk through that a little bit. How easy is it to do that? I mean, talk about scientific advancements.
Yeah, we wouldn't be anywhere near where we are in our institutional and in my personal understanding of that concept if it wasn't for Dr. Deepatosh Das, who hasn't even been with us a year yet and has just really accelerated our understanding. When it comes to just measuring the EH or the redox potential, which would just be an ORP value, you could get an ORP meter and measure that. That's pretty straightforward. And pH, you do want to measure the pH of that substance as well, because to get a true redox potential, it does need to be a combination of multiple variables. And so we're learning a lot. It is time intensive to get a redox potential of a plant, for example. So I guess my response to your question is measuring the redox potential or the EH of a plant or the soil versus a product are two totally different things. And it is much more difficult to measure the EH of a plant or the soil versus a given product. And yeah, like I said, a credit to Dr. Das, who's got us at a level where we have, we're building a database and we're calibrating to understand what are those optimums in a given cropping system and in a given environment where we want to be. And the reality is plant and animal life, including microbial systems, are governed by those principles, by EH and pH. And so it's a really exciting place to be. It's a new agronomic perspective that we're really excited about.
Wonderful, and I totally agree on Dr. Das. He's been phenomenal. Our second PhD here in the office, very hard worker, and we're gonna see a lot of results from that moving forward. As growers have questions, they can certainly talk with our agronomy team as well as our scientific team to get answers. Of course, we're still in the discovery phase as well. You mentioned the questions that should be asked, which is a great item to talk about. There's a book you have that you really like. Tell us about that.
Yeah, if people are interested in more information on any of the biostimulant categories, this one, but particularly humic substance, biostimulants for sustainable crop production, this has been a really good resource. I get it. This is basically a summary or an accumulation of the scientific literature. I get not everybody likes to read that, but there is tables in here that are very specific. I think page 55 is the one for humics, and it goes through all of the different plant responses from selenium toxicity and how humic substances can help with that, and different ways to utilize humics. And it's just very specific in a table. If you don't like reading scientific literature, it's still a great resource and something that has been highly valuable for us in distinguishing bioactive compounds and benefits of different biostimulant categories to solve solutions for growers in the field.
When you have more than 1,000 companies in this category, there certainly are some that are talking the talk and not walking the walk. I want to know about our research that we carry out, whether it's working with growers, universities, third parties. The information that we're presenting here, and we're learning more every day, but it's based on science and repeated information. Talk about that, and also the importance of having repetition in getting the results that we can feel comfortable with, and a grower can be assured they're going to have consistently positive results.
There's a lot of breadth and depth there. You've probably seen in one of my presentations where I literally have a visual for that breadth and depth. And you've also heard the conversation or the point that I made that we're always increasing our breadth, right? In terms of where that research is done with universities, with NGOs, with third-party organizations, practical farm research with growers here in the greenhouse, in our own research farm and in our back door. And then on the technical side, less applied, right? With EH, that's very, very much a more technical agronomic tool that we're developing. And so that breadth is extensive, and the depth gets extensive. We already talked about soil respiration. Some of the other benefits or things that we have identified with H85, for example, with the research that has been done, in addition to reducing nitrate leaching and increasing soil respiration and enzyme activity, the other one was an increase in fungal to bacterial ratios is another thing that we've identified. And so some of those things we've collaborated with a lot of startup VC companies too to help them calibrate technology. It's a very exciting place for a scientist to be able to have access and to work and collaborate with those individuals. We have some very exciting results that are in the process. And what's really unique from a scientific standpoint, when we look at the assays and the approaches and the methods that are being used to quantify different benefits in agriculture, quantify mode of action, because that's what we're at, and that's one of the criticisms of biostimulants and all companies in that marketplace is, okay, it works, why does it work? Mm-hmm. Being able to answer that question. We've got some really exciting research that we're going to answer some of those questions based on the hypotheses that we have formed from the literature and what we know about our products and what we know about our plant extracts and our different biostimulant categories. So we're really excited to unveil that, and perhaps it's a discussion in the future that we can continue.
Yeah, it's a very exciting time, and really appreciate your time and your comments, Giff. We'll be certainly doing more of these discussions. There's so much to tell, there's so much to share, there's so much more to learn, but it's surely an exciting time here at Redox. I appreciate your time very much.
Thanks for the opportunity, Jim.
Yeah, and thank you for joining us. We will be having this as a periodic podcast where we take a deeper dive. Hope you enjoyed it. Send your comments to podcast@redoxgrows.com. You can, of course, go to our website at redoxgrows.com to find out more. Take care.